All right, and jumping into part 2 of this iteration lesson, we are going to talk a little bit about the map family of functions. I generally think of map as you may also on Stack Overflow come up across iterative functions or seeing people use this idea of apply functions very often, which we can share some resources on both of these. But I sort of think of map as the tidy versus apply function. And so, yes, map functions live inside the tidyverse. Specifically, they live inside the package called purrr in the tidyverse, and purrr has, I don't even know how many R's, maybe 4. But so make sure that you load in your tidyverse in order to use map functions. And map functions generally take 2 different arguments. This is the columns that you want to iterate over and the function that you want to execute on those columns. So taking a step back, when to use for loops versus when to use map functions can be a little tricky, and this is certainly not a hard and fast rule, but generally map functions are going to iterate across columns, and I personally tend to use for loops down rows. You can certainly do more than that with for loops, but the default for map functions is saying, I want to use a function and I want to use it on lots of columns all at once. That can be our base understanding of how to use map. So some examples of this, you can start with the most generic function. We'll note if you have loaded in the tidyverse and start typing in map, and you have sort of your auto prompt of different functions, you'll see that there are loads of map functions. And so there's lots of special features here. There's sort of, and this comes down to thinking about the input and the output of your map function, just like with for loops. So we'll get into it. But we'll start with just the most basic map function, just map open parentheses. And that, like I said, takes 2 arguments. So let's say we want to do something to the iris data, and that something being we want to take the mean of every column in the iris data. Just a reminder of what the iris data is. A bunch of continuous variables, and then a species column. So if we map iris comma mean, we want to take the mean of every column in iris. And we get a warning that we'll get to in a second, but we see our output is, it looks about right, sepal length, and then a single value that could very well be our mean, sepal width, all have single values. And then our warning is that we have an NA for species because it doesn't know how to take the mean of the column species, so it just autofills it with an NA. Not bad. This output, though, thinking about inputs and outputs, is we gave it a data frame, but by default map outputs a list. And so there are some specialized map functions that help maybe output it in your desired output. So in this case, we can say, I put a data frame in, I want a data frame out. You can use the map underscore df function. And so anything that follows the underscore is the desired output of the map function. So if we do map underscore df, and then inside the parentheses, iris comma mean, we get a really similar output, but instead of a list form, now it's a tibble. It looks a little more familiar. We have different column names with the different mean values, but we still have an NA for species because once again, still doesn't know how to take the mean of a species. But so thinking about what it is you put into this map function, we can use our subsetting brackets to be a little more specific rather than say, I want you to take the mean of every column in the iris data frame by just giving it iris. You can specify the columns that you want this map function to iterate on using brackets. So you can do map underscore df, open parentheses, iris, but then use your square brackets 1 through 4, because now that we've been looking at the data, we can pretty much tell that it's columns 1 through 4 that have continuous data, and then take the mean. And when you run that line of code, the output is now just the 4 columns. It's dropped the species column. Okay, but we learned about writing functions last week for a reason, and it's that really often these iterations are usually paired with functions that you are writing personally, or that's where some of the power can really come from. So we can go ahead and do that. And so for this case, we're just going to come up with a pretty simple example, which is we have our empty cars data set, and we know that our row names of empty cars represent different cars, and we have this miles per gallon column. So also last last week we learned about the paste function, which can paste together values and characters to give a character string output. And we did this with dates, and we can do it with words as well this week. So let's say I want to do a thing. I want to print out a sentence for every row in this data frame, where I want to combine together the car name and the miles per gallon for the car with some other text. We're going to write a function to do that. We're going to call it print underscore miles per gallon. We're going to use our assignment arrow and then call on our function operator. And this function is going to have two arguments, x and y. So we'll do function x comma y, then open up our curly brackets. And remember, inside the curly brackets is where the operation action happens. And so the operation that we want to happen is we want to paste a value of x, which will eventually input as the car names. We want to paste it with the word gets. So we'll do x comma quotation marks gets comma, then a y value, which will eventually put into the miles per gallon column, comma, and then quotation marks miles per gallon. So again, remember, if we you want to make sure that you run the whole function either by highlighting it or putting your cursor at the end of the curly brackets. And this won't run anything. It will just save the function into your global environment. And then what we're going to do is use the map to function, which so previously we had functions that just had one argument. And so we didn't really have to specify it. Like the mean function just has an argument of x, and it knows to iterate through on every column of iris. But you can get a little more specific with these more detailed map functions. Map2 is one of them, and it's at least transparent. Map2 takes two specific arguments, so an x and a y. And we can do map2 underscore character because we want our output to be character data. And our two arguments that we want to specify are that we want to take the row names of empty cars. So remember, the car names are not actually a column name, it is the row names. And if we inspect that on its own, you'll see the different car names printed out if you just run the line row names empty cars. And then we want to, our second argument y, so will be the y in our argument here is the miles per gallon. And so just like with before, map functions take input and a function. Now map2 functions take input 1, input 2, and a function. And so you'll do map2 underscore character, your x and your y values, and then you can just put in your function as you've named it above into the third argument in this map2 function. And when you run this line of code, you get the expected output, you have a character output, and now where we had previously put just sort of this conceptual X argument, we have the row names. Where we had put the conceptual Y argument, we have the miles per gallon of empty cars, and we have pretty sentences about the miles per gallon of every car. Had to turn on that light and it's a little intense. Okay, and then the one last thing we'll show you, because it comes up like if you're on Stack Overflow and you're looking at how to iterate, you'll see this with map. You'll also see it with a family of functions called apply, which I said map is sort of the tidy versus apply. The logic is similar, though some of the syntax is the same. But there are, in either case, there are two options. One is you can do what we just did, which is write a function, save it to your global environment, and then just leave it sort of unspecified as your third argument in the map function. Or you can embed a function within the map function in what we call an anonymous way. So it's not saved to the global environment. In this case, it's not named anything. And there is a slight difference in the way you write it out, which is that you ditch the curly brackets. So what this looks like, similar to how we started before, you can do map2 underscore CHR. You still want your X argument to be the row names of empty cars. You still want your Y argument to be empty cars, $ miles per gallon. But instead of just writing in print underscore miles per gallon as a pre-saved function, you then open up your function call, like we're starting to get into the habit too in function writing. You still say there is an X and a Y argument, but you do not include a curly bracket as we have been after this function call. Instead, you just dive right into the operation that you want the function to be, which is still paste X with gets Y and then with miles per gallon. and you close out your parentheses. So it all looks the same, ditching the curly brackets, but it now lives as this sort of anonymous function argument inside your map function. And when you run this line of code, you get the exact same result as before. It's just two ways to get to the same thing, and is worth seeing because sometimes some are more useful than others. And great, we will start practicing this in class, and I'll see you then.